So hello नमस्कार टू द ऑल डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर एंड केमिस्ट्री लवर। मैं विजय कुमार सोनी आपका हर बार की तरह केमिस्ट्री चैनल में स्वागत करता हूं रिगार्डिंग टू जस्ट केमिस्ट्री। हम प्रीवियस वीडियो में बात करें तो पर्टिकुलर न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन की रिगार्डिंग 4 इंपॉर्टेंट रिएक्शंस की बात कर चुके हैं। आज बात करेंगे फिफ्थ रिएक्शन की, दैट इज सब्स्टिट्यूशन बाय, दिस इज द फिफ्थ रिएक्शन, सब्स्टिट्यूशन बाय alkoxy group. If we'll go with this reaction, substitution by alkoxy group, then it is also called as Williamson synthesis. Williamson synthesis also. What is the reaction? If we'll go with the just sodium salt of carboxylic acid, this is the sodium salt of alcohol, this is the sodium salt of alcohol, and here is the alkyl group. Then here will formation of electronegativity of halogen is larger. Here electronegativity of oxygen is larger than the sodium, so here will formation of ROR as a ether, and rest it will formation of NaX. This is the ether. If we will go with the just R is equals to C2H5, OC2H5, just ONA. Here is your, we can take Br C2H5. Then by the substitution, the reaction will be as follows: plus, this is plus and minus. So C2H5, OC2H5. You can say diethyl ether, plus it will be formation of NaBr. If you will go with the type of the ether, then there are two types of the ether. You can say this is the ROR dash. Here is the two types of the ether. When R and R dash both are same, R is equals to R dash, then they are known as symmetrical or simple ether. And if both are different, R is not equals to R dash, then they are known as asymmetrical. This is the asymmetrical or mixed ether. If we'll go with the example, then we can take just as example, this is the CS3, OCS3 as a simple, and CS3 OC2H5 as a mixed ether. So from this method we can get both ether as well as symmetrical and asymmetrical. So what we can say, both symmetrical and asymmetrical ether are possible from this reaction, This is the most important thing regarding to Williamson synthesis. Now I would like to go with the sixth reaction. What is that? This is the sixth reaction as a substitution by nitrite group. As a nitrite group, we will take just ONO. This is the ONO. For the formation of just nitrite derivatives, we can take over here as a, this is your RX alkyl halide. Here we'll use either NaNO2 or KNO2. Both we can use. These will be dissociated as follows: Na plus ONO, and here this will be as a K plus and ONO. This is the minus. So by the removal, here will formation of like this. This is the minus and plus. This is the minus. So here will formation of R NO alkyl nitrate with the formation of, if we are using NaNO2 sodium nitrate, then here will formation of NaX, and for the use of KNO2 here will formation of Kx. This is the alkyl nitrate. If we'll go with the example, then we can take as a C2H5. This is the Br. This is the NaONO. This is the NaONO. This is the plus and minus, minus and plus. Here will formation of C2H5ONO, and here is your NABr. NABr. This is called as ethyl nitrite. Ethyl nitrite. So this was about the substitution by nitrite group. Now I would like to go with the seventh reaction. What is that? Substitution by nitro group. This is the nitro group. As a nitro group, we can use NO2, not to be ONO. This is the nitro group. If I'll go with the substitution by nitro group, then we will take just alkyl halide. First of all, this is the alkyl halide. This is the AgNO2, alcoholic. If I'll go with the structure, then it will be as follows: Ag, N, this is the double bond O, this is the O. As you all know, just here is the Ag silver metal, so its nature will be covalent, while its nature is ionic nature. So due to covalent nature, attack of attacking group will be as follows: R will attack from the back side of the nitrogen. That's why here will formation of R. This is the NO2, nitroalkane. This is the nitroalkane, and here will formation of AgX. If I'll go with the just R is equals to CH3 CH2, this is the Br. This is your AgNO2. So this is again your alcoholic. So attack will be as follows: minus and plus. This is the plus and minus. Here will formation of CH3 CH2 and O2. This is called as nitroethane, and that rest is your HAgBr. This was about the formation of the nitroalkane, nitroethane. If I go with the NO2 group, then it's very important function group, because of NO2 can be changed in further also by using the 6 of H in the presence of SN or HCl, acidic medium, or you can use Fe or HCl also, anything regarding to this catalyst. So 6 of H, about the 6 of H, 4 of H will react with the just 2 of oxygen to give the just 2 of H2O, and rest 2 hydrogen will be over the nitrogen and changes in 1 degree amine. This is the 1 degree amine, and this reaction is too important for the interconversion. This is important for interconversion. Interconversion. So this was about the substitution by nitro group. Now I'll go with the further. Just this was about the fifth, sixth, and seventh, and we'll go with the further also. Now the time to discuss about the eighth nucleophilic substitution reaction. What is that? Listen me carefully, because of these all reactions are very important, and these reaction completes to the 20 question of the NCRT as an important question for the interconversion. So be careful, learn each and every reaction properly by the writing practice, otherwise it will be a blunder mistake by you. So this was about the just your substitution reaction. Now I would like to go with the eighth reaction, substitution by carboxylate group. This is the eighth reaction, substitution by carboxylate group. Substitution by carboxylate group. If I'll go with this reaction, then here we'll use sodium salt of carboxylic acid. This is the RCOONA. This is the alkyl halide RX. Electronegativity of again X is larger than the just alkyl group we have discussed properly. Here will be positive charge, here will be negative charge. So here will formation of RCO. This is the O. This may be R dash also. So R dash plus NaX. This is the NaX, and here will formation of ester. If I'll go with the reaction, then we can take R is equals to CS3 COONA. Just this is the COONA, and this is your plus and minus. Here will your this is your Br. This is your, you can say, CS2 CS3. Then what will be? Here will removal of Br minus and plus. So here will formation of, we can take over here. This is the CS3 CO O. This is the CS2 CS3, and this is your NaBr. This reaction may carried out by using the silver salt also. So this is the silver salt of carboxylic acid, RCOOAG. This is the X and R dash. So here will formation of, as usual, silver salt and further formation of ester. This is the RCO OR dash and plus AGX. This is called as ester. Here is the ester. If we'll go with the example, then we can take CS3 COO. This is the AG plus this is the Br and C2H5. C2H5, electronegativity of Br is greater than carbon, and here is the greater than silver. So here will formation of CS3 COO C2H5 plus your AgBr. This one is called as just ethyl acetate as a common name. Ethyl acetate as a common name. This was regarding to the substitution by just carboxylate group. Now I would like to go with the substitution by amino group. This is the ninth reaction. Substitution by amino group. This reaction is also called as Hoffman just ammonolysis. Hoffman ammonolysis, because of from this method it will formation of the mixture of 1 degree, 2 degree, 3 degree amine with the formation of quaternary salt also. So this is the axis of alkyl halide. This is the axis. Here is the alcoholic ammonia. Then what will be? by the removal of HX, here will formation of R and S2 as a 1 degree amine as HX. This is the 1 degree amine again. This is your alkyl halide, another molecule. Electronegativity of X is greater than R. Here will removal of HX. So formation of again your 2 degree amine like this. RNHR plus this is the HX. This is your 2 degree amine. And if we'll go with the further R and R and H, then again alkyl halide reacts to give the 3 degree amine like R and R and HX. This is the 3 degree amine or tertiary amine. And if we go with the just again, then this amine 3 degree amine due to presence of lone pair again on reaction with alkyl halide gives you just quaternary ammonium salt R. This is the N, this is the R, 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 and this is your positive plus X negative. This is called as quaternary ammonium salt. Ammonium salt. If we'll go with the name, then we'll say here is the tetramethyl as a tetraalkyl. So also called as tetraalkyl ammonium halide. Ammonium halide as a quaternary ammonium salt. And this was about the ninth reaction as a substitution by amino group. Now the time to discuss about the 10th important substitution reaction. What is that? Listen me carefully. This is your 10th reaction as a 10th reaction substitution by mercaptide group. This is the most important for the point of interconversion also. If we go with the just substitution by mercaptide group, then here we can use sodium salt of just thioalcohol like this plus and minus. Here we can use alkyl halide, and here will formation of just electronegativity of X is greater than R. So here will formation of RSR plus here will formation of your NaX. So here will formation of thioether. If I'll go with the just R is equals to C2H5, this is the S, this is your Na plus and minus, this is your Br minus and C2H5. So by the removal of NaBr, here will formation of C2H5 SC2H5. You can say diethyl thioether. Diethyl thioether. Now I would like to go with a just adduct also, then that will be as a NaBr. If I go with this reaction, then this reaction may carried out. This reaction may carried out by using Na2S, sodium sulfide. Na2S. How? These are the two molecules of alkyl halide, Rx and Rx. This is the NaS and this is the Na. Here will removal of 2 of NaX and resultant it will formation of thioether. Thioether as a dialkyl thioether plus here will formation of the 2 of NaX. If I'll go with the example C2H5, this is the Br. C2H5, this is your again another molecule on reaction with Na2S. This is the Na2S. Here will removal of 2 of NaBr similar to this reaction and formation of it will be diethyl thioether. This is the C2H5 diethyl thioether and removal of just you can say 2 of NaBr. 2 of NaBr. This was about the 10th reaction and now we'll go with the very important reaction for the interconversion through which you can change to a alkane in alkyne also. So what is that? Listen me carefully. This is too important. So this is the 11th reaction. Substitution by alkynyl group. Alkynyl group. In low standard as a class 11th you have discussed this is the alkane. As a alkane you are going to take just ethane. This is the ethane. As a alkene you can take ethene like this. Ethene. As a alkyne you can take just ethyne like this. Ethyne. If you will go with the ethane, then here is sp3 hybridization. Here is your you can say sp2 hybridization over the carbon of alkene, and for alkyne it will be sp hybridization. This is the hybridization. If you will go with the just sp3 hybridization, then this exists 25% as a S character. This exists 33.33% as a F character. And alkyne means due to having sp hybridization, this carbon exists 50% as a S character. And you all know percentage of S character increases, then just you can say nuclear force of attraction also increases, size decreases, resultant electronegativity also increases. Due to this reason, this carbon is more electronegative than the alkene, and carbon of the alkene is more electronegative than the alkene. That's why whenever just alkyne reacts with the sodium metal like this, then it will be a removal of just you can say 2 of CH C.Na. This is the plus and minus. Here will release of H2 gas, and this is called as sodium ethynyl. This reaction may carried out by using just sodamide also, because these two reactions are regarding to the acidic character of the alkyne, because of here is the loss of H hydrogen. That's why these two reactions are regarding to the acidic character of alkyne. So we can use any NS2 as a you can say sodamide. So whenever it will use of sodamide, reaction will be as follows. Here will formation of CH triple bond C. This is the Na. Again you can say sodium ethynyl, and here will release of NS3. These two reactions are very important, because of these two reactions are helpful to explain the acidic character alkyne. Now by using these two salt, these both are same. By using these two salts, you can change alkyl halide in alkyne. This is the RX. This is the sodium salt. This is the minus triple bond, the CH. So by the removal of NaX, here will formation of higher alkyne C triple bond CH plus NaX. This is the higher alkyne. If you want to get just methane to propine, then first of all you have to react the methane with the just chlorine. So it will be methyl chloride like this, CH3Cl, and further on reaction with sodium ethanide, what will be reaction will be as follows. This is the minus and plus. Electronegativity of Cl is larger than the carbon, so here will formation of propine, C triple bond CH plus NaX. Here will formation of the propine. This is the reaction through which we can change methane in propine. So this was about the just entire part of the substitution reaction. So we will meet in the next video. Till then, शुक्रिया, धन्यवाद. आप लोगों से सभी से एक ही गुजारिश है, आप लोगों के सपोर्ट की मुझे रिक्वायरमेंट है ताकि मैं ज़्यादा से ज़्यादा इस केमिस्ट्री को लोगों के साथ में शेयर कर सकूं आपके साथ साथ. नो डाउट कारवा बनेगा तभी काम चलेगा. तो आप लोगों के सपोर्ट की जरूरत है. इसको ज़्यादा से ज़्यादा सब्सक्राइब कीजिए, शेयर कीजिए ताकि ये उन बच्चों तक भी पहुंच पाए जिनकी पहुंच से बहुत दूर है. धन्यवाद, शुक्रिया.